The unavailability of labels for many real-world datasets is often the bottleneck in supervised machine learning applications. Today, scientists are often overwhelmed by thousands or even millions of unlabeled records and datasets, all of which are thus unavailable for supervised machine learning. In this video, we introduce mVis, a tool that helps partition a multivariate dataset into labeled classes. mVis enables analysts to label records and create partitions of a previously unknown dataset in an effective and efficient way. While analysts may start without any knowledge about the dataset and the label alphabet, the output of the implemented approach is a labeled training dataset which can be used for supervised machine learning. To demonstrate the application, we use a football dataset of players from 16 clubs participating in 5 top European leagues in the 2017-2018 season. The records are the individual players. The dimensions are players' attributes such as the number of match appearances, committed fouls, assists, pass accuracy, and so on. The dataset comprises 318 records and 13 dimensions. mVis has 3 main components: visual exploration, interactive visual labeling, and automatic guidance. The dataset can be explored interactively using a palette of linked visualizations, including a scatterplot matrix, scatterplots, similarity maps, and parallel coordinates. Records can be selected and labeled in any of the interactive views, leading to labeled datasets which can be used for supervised machine learning. Records which have been manually assigned to a partition or approved by the analyst are considered to be ground truth and are represented by solid circles in the scatterplot matrix, scatterplot, and record similarity map. Various machine learning algorithms are implemented to support the interactive labeling process, including dimensionality reduction, clustering, classification, and active learning. All of these algorithms are implemented using the Java library called DMNML. At any stage, the analyst can perform clustering by clicking on the clustering button in the partitions panel. The system will then cluster all currently unlabeled or unapproved records using k-means or hierarchical clustering. By default, mVis uses k-means, but the user can change the algorithm by selecting hierarchical clustering in the menu. Suggested records after clustering become hollow circles and are recolored to the suggested partition's color until either approved or rejected by the analyst by clicking the Reject or Approve buttons next to each partition in the panel. Suggested records which are rejected become solid red triangles again and are moved back into the unknown partition. Approved records become part of the partition and are henceforth represented by solid circles. Alternatively, once sufficient records have been assigned labels, the analyst can run a classifier to classify those records which are currently either unknown or unapproved. The system then runs a random forest classifier using the already labeled records as a training set. The user can control the number of suggestions by adjusting the similarity threshold with the slider next to the classification button. While the slider is adjusted, a number indicates its precise value. With a higher threshold, only those records more similar to a specific partition will be suggested. Similar to clustering, the analyst can then approve or reject the classification result. Periodically, the system actively guides the user to label a number of records using active learning manually. The suggested labels can either be approved or rejected. The number of suggested records can be fine-tuned, and active learning can be turned off completely with the checkbox in the partitions panel. During the labeling process, dimensions that the user interacted with to perform labeling are added to the label as metadata. This solution facilitates labeling without the need for domain-specific visual representations by leveraging the structural information provided within a multivariate dataset, such as patterns and relations between records and dimensions. Using a new automatic dimension selection technique, interactions of the user with specific data and dimensions are remembered and fed into the semi-supervised and supervised machine learning techniques. For example, if the user selected records in a scatter plot of dimensions, goals, and assists, and added these records to a partition, then dimensions, goals, and assists are associated with that partition. Initially, dimensions which users have not interacted with play no role in the machine learning algorithms, but the user has final control over which dimensions should be included in or excluded from the machine learning algorithms.